knew what the side length of the pond was and how many sides there were. So we multiplied that by the number of, what are those things called?
Probably the side length or the number of sides.
Or no, the amount of fencing.
All right. So if we have our side length, we can get our amount of fencing, right? So if the side length is 1 for each side, how much fencing would you need?
4 feet.
If it was 2, how much would you need?
8 feet.
If it was 3, what would we need?
12.
What if it was 4?
16.
And what if it was 5?
20.
All right.
25. Why did I put? What am I doing?
No, that's right. 20's right. 5 times 4 is 20.
Oh, I put 23 for some odd reason.
All right. So looking at this, what do you notice about the amount of fencing to the side length? It's what?
Proportional.
It is proportional. Why?
Because it's a constant.
What is the constant?
2. 4. I mean 4.
All right. How do you get 4?
Because 2 times 8 is 4. 3 times 12 is 4. 4 times 4 is 16. And 5 times 4 is 20.
All right. So, or we could say 4 divided by 1 is 4, 8 divided by 2 is 4, 12 divided by 3 is 4, 16 divided by 4 is 4, and 20 divided by 5 is 4. All right. So we can either find our quotient or we can find what we multiply our x by to get our y. So that works out perfect. Good. So our table's done. All right. The next thing we were supposed to do is write a rule. All right. What rule did someone come up with? What did y'all come up with? Somebody tell me what you came up with.
I have one, but I don't think it's really like that.
Anybody else got one other than Madeline? I talked with everybody's group. Somebody should have one. Madeline just went. Somebody else should be able to go. Oh, come on, people.
Can I just say one?
Go ahead, Madeline.
I don't know if this is really a rule because I don't understand that much of the whole algebraic rule thing. But can it be like you multiply 4 by each, or I don't know how to say it.
I think you're saying it right. 4 times each what?
Side length.
Correct. So if we do 4 times each side length, what variable could we use for side length?
S.
Yes. And it says to let F represent the amount of total fencing. Would 4 times S give us the total amount of fencing?
Yes, sir.
Yeah, it would. So that is perfect. Rachel, did you have a different one than that?
No, sir. I had the same thing.
Had the same thing? All right. How did you come up with it? What did you think?
I put 4S is equal to F.
All right. So how did you know to do 4 times S to get F?
Because S is the side length of the pond, and it's 4.
All right. And there's 4 what?
4 sides.
There you go. All right. So, yes.
Could another rule be 4 divided by F equals S? Or is that not right?
Let me see. So F divided by S would give us 4. If we did F divided by 4, you said it would equal S?
Yes, sir.
Yes, you're right. Good job. All right, so that would tell us how much the side length was. So if they gave us the total amount of fencing, we could figure out how long each side would be by doing what you just said, Madeline. Perfect. All right. So Rachel and Madeline y'all got it going on. All right. Trying to give my people some points. Cool. Now, the last thing we had to do was do a graph. we're just going to look at their graph and see if it's the same as ours. Pretty sure it is, if you graph this correctly. All right, so looking at this, what do you notice about this graph, and is it different than your graph that you had? Try it again, couldn't hear you. Vincent's group, did your graph look like this?
Yes, sir.
All right.
Everybody's leaving and then coming back.
Yeah, I know. I don't understand what the deal is. All right, Vincent.
Like, calling their name and it logged out because of my internet connection.
I got you. Vincent,
Oh, I thought we were still on the other problem.
I got a question for you. You ready, Vincent?
Yes, sir.
Every time we go one to the right on the x-axis, what happens on the y-axis?
I know the answer. It goes over.
All right. In other words, every time we go over one to the right, what is happening on the y-axis?
It's moving along with it.
All right.
Or either going upward.
How much is it going up?
By 4s.
There you go. That's what I'm looking for. Since it's going up by 4, that tells us automatically what our constant of proportionality is. That means that every time we move 1 foot to the right, or every time for every 1 foot, there is 4 feet of fencing. All right. Another way we can tell what our constant of proportionality is because where 1 is x, our y is our constant. So if we look at an ordered pair and it's written like this, and they give us 1 for our x, whatever this number is right here is automatically going to be our constant. All right. So if you're looking at a graph and you know it's a constant of proportionality, and it's constant, if it's a proportional graph, you know it has to be a straight line that passes through the origin. Remember, the origin's right here. All right, so that line has to be able to go through there if you were to connect it. All right, if it's a straight line that passes through the origin, then our constant, we're looking for where 1 and y meet. Well, 1 and y are meeting at 1 to what? Where's this line crossing the x-axis?
Origin.
No, look, x is this way. Where is y and x meeting? What is that point right there called? What is that point? No. No one knows what that point is? I'm going 1 to the right and up how much?
What it was called.
It's not, it's just an ordered pair. What is the ordered pair for that point? 1 to what?
The proportion?
No.
The constant?
1 to what?
Oh, 1 to 4.
There we go. Y'all are making it too difficult. 1 to 4. Good. Since 1 is our x, y is our constant, which is in this case is what?
4.
4. All right. Also, f equals 4s is written in the form y equals k times x. Since it's written in this form, we know that k is our constant. Okay? So f is equal to y, 4 is equal to k, and s is equal to x. So that automatically tells us that our constant is 4. Also, we should know that the constant is the coefficient that's being multiplied by x. In this case, the coefficient is 4. All right, in the table, we know that we can find the constant of proportionality by doing y divided by x to get our k. All right. So if we get the quotient of every one of these, 4 divided by 1 is, woo, y'all better speed it up.
4.
8 divided by 2 is,
4.
12 divided by 3 is,
4.
16 divided by 4 is.
4.
So that means our constant of proportionality is what?
4.
Why?
Because it's a constant rate of 4.
That's correct. Every one of those quotients are 4. Okay? Does anybody have a question about that? If you don't, then you can answer in your book the next question in your book. Okay? I'm pretty sure it asks a question like that. What does it say for number 2 in your book on page 89? Nobody?
It says,
there we go.
Study the table graph and algebraic rule for the fencing scenario. Is a relationship between side length and fencing needed proportional?
All right. Is it proportional?
Yes.
Yes. What's number 3 say? Or what's that next part of the question?
Number 3 says, if you found a proportional relationship in question 2, identify the constant of proportionality using each of the representations. Explain how you found it in each case.
All right. Is that what we just did?
Yes.
Yes. So I want you to put what we just said for your answer on number 3.
Okay.
All right. So how do we tell what the constant is by looking at that table? Speak up or I'm going to call on somebody.
Dividing 4 by 1.
Good. All right. And what else? What else?
Can you
Correct. Every one of those, when we find the quotient in that table, we're getting 4. So that's how we know that the table has a constant of proportionality of 4. What about the algebraic rule? How do we know that it has a constant of 4? Hagen?
Because for one fence, it's 4 feet.
Okay, good. Also, we know if it's in the form of y equals k times x, and 4 is in k's spot, then it's what? What does 4 have to be? Help him out, somebody. I got it drawn on the page.
The constant.
There you go. Oh, good, Hagen. We couldn't hear you. Your computer started cutting out. All right, and on the graph, how do we know how to find the constant by that graph? Go ahead, Rachel.
By looking at the x and y axis,
Good.
you can that they're divided by 4 or multiplied by 4.
All right, but on the graph, what about on the graph? When you're looking at that x and y axis, don't every time we go to the right 1 foot, it goes up how many feet in fencing?
Four.
There we go. Good. All right. Anybody have a question? All right, moving on. Page 8. All right, read this for us, please, Miss Alora. What in the world? I just erased that. Did y'all see that?
It came back.
That's crazy. Alora staring off into space.
No, there's noise in my background.
I'm picking, girl. Can you read that for us?
Okay.
Thank you, ma'am.
Compare the graphs representing the two pond scenarios. Both graphs share a constant rate of change. The graph of the fencing scenario represents a proportional relationship. In a proportional relationship, the rate of change is the constant of proportionality. Any two ratios in the relationship are equivalent.
Thank you, ma'am. You did good. All right, so looking at this, Braden, what do you notice about the border tiles, that graph? What can you tell me?
About the order trials, I could tell you that they're going up 4 each time.
Okay. Do you notice anything else about that graph? All right. Does anybody have anything to add to what Braden said?
It's not going through the origin.
That's right. It's not going through the origin. And if it's not going through the origin, what does that mean?
It's not proportional.
There we go. Good. All right. So looking at the other side, what do you notice on that one?
It's going through the origin and it has a constant of 4.
All right. And it's what type of line? Is it curved or crooked or straight?
Oh, it's straight.
Yeah, it's a straight line. And so there's two requirements for us to have a proportional relationship. What are those two requirements? Go ahead, Rachel.
It's straight and it has to go through the origin.
All right, that's right. All right, so it has to be a straight line that passes through the origin. All right, tell me this. Does it have to pass through here? No, it does not. That does not matter at all. I had a kid in one of my classes ask me, "Well, it's not going through there." That doesn't matter. It doesn't matter what happens up there. Doesn't matter what happens over here. Doesn't matter what happens over here. All that matters is it has to be a straight line. It can go at any angle, and it has to pass through right there. That is 0, 0. That is our origin. Does that make sense?
Yes, sir.
All right. Does anybody have a question about comparing those two and understanding why one is proportional and why one is not? It's a great time to ask. All right. Give me
Mr.
it.
Martin, I just joined. I just because I had some internet problems a while ago.
That's cool. All right. So basically, all we said is that the graph on the left is not proportional because it's a straight line that does not go through the origin, and the graph on the right is proportional because it's a straight line that does pass through the origin. All right. So if you understand this, give me a thumbs up with your nod. If not, give me a thumbs down. All right. Looks like everybody's good to go. I'm going to move this over to Marion blew the whistle. Here we go. He said, we're good. All right. We'll get this off of here. We're going to go to page 9. Page 9 is going to have a question for number 4 in our workbook. We should have been able to answer 1 through 3 already. All right. So, Sophia, I want you to read this without adding anything into it. I just want you to say blank.
The graph of proportional relationships is a blank that passes through the blank. The constant of proportionality is the blank. You can find the blank by comparing blank between pairs of values in the graph or the table. In the graph of a proportional relationship, the y value at the point 1y also tells you blank and blank.
Wow, that was a lot of blanks. All right, here we go with that information. You have 6 phrases or words that you can put into the blanks. One of those words will not be used. Some of the words will be used more than once. So I want you to take right now on your own, all by yourself, independently, and I want you to figure out what is the correct order that those go in. All right? I'm going to give you about 3 minutes to do that. It's 1:37 now, so at 1:40 we'll take a look at it. All right, let's see what we got. I'm gonna just randomly call on people. Okay, so the way this is gonna work. I'm basically going to let somebody read the sentence part. Then I'm going to call on somebody to tell us the answer. Then I'm going to call on somebody else to read the next sentence part. And then I'm going to call on somebody to tell the answer. Sound cool? Laura said it's confusing, but we're going to make it work. I saw her face. All right. So Hagen's kind of like, oh my goodness. Let's see what happens. Hagen, you're going to start this off.
Graph of a proportional line is a. Do I read what I put?
No, I want you to say the graph of a proportional relationship is A. That's what I want you to say.
The graph of a proportional
Vincent is a what?
Constant of proportion.
All right. He said maybe it's a constant of proportionality that passes through something. Do y'all agree or disagree with that statement?
I disagree.
All right. What do you think, Rachel?
I think A is a line.
All right. What do we think, class? Does that sound good? Do we agree or disagree?
I agree. I think it's a line.
All right. So think about the graph. Think about it's a straight line. Then it says what, Sophia?
that passes through the.
What, Hagen? What does it pass through? Good. The origin. All right. Homogeneity. Read the next part.
The constant of I don't know how to say that.
Proportionality.
Proportionality is the.
What, Kalia?
The constant of proportionality is the rate of change.
All right. Do we agree or disagree?
Agree.
I agree. All right. What's it say next, Akira?
You can find the.
What, Braden? You can find the what?
You can find the. Well, you can find the constant of proportionality.
All right. I think Akira and Braden both said that one. By comparing the what, Madeline?
Constant of proportionality.
Oh, do you agree, Angel? Think about a table.
Huh?
Think about a table. You can find the constant of proportionality by comparing the what on a table? I think Madeline's is messing up. Somebody tell us. The what?
By comparing the
Ratios. Okay.
I was going to the pairs, but.
Yeah, so when you think of ratios or pairs, so that's talking about like earlier we were saying 1 to 4 and 2 to 8 or 3 to 12. So those are ratios, but they're also ordered pairs. You're correct. All right, keep reading that for us, please, Miss Hamarjane.
Between the pairs of values in the graph or in the table, the graph of proportional relationship, the derived value of the point 1y also tells you the.
What does it tell us, Brooklyn?
The constant of proportionality.
All right, and what else does it tell us, Layla? Help her out, Tamarion. What else does it tell us?
Intercept.
Have we ever used intercept?
I don't know.
All right, so if you don't know what it means, what does something that you do mean that could go there? What's the same thing as the constant of proportionality, Tom Marion?
Rate of change.
All right, do we agree?
I agree.
All right, give me a thumbs up if we agree with what Tamarian just said. He said the constant of proportionality and the rate of change. Look at that, Tamarian.
Oh my gosh, they love me.
That's what it is. All right, so let's see if we got it right. Woohoo! All right, so now what we'll do is we'll let Mr. Vincent go through and read the entire thing for us. Vincent, read that whole thing for us. Make sure that we're writing this down in our workbook. Vincent's taking too long. Somebody else read that. Brooklyn, read that for us. Brooklyn's taking too long. Braden, read that for us.
The graph of proportional relationship is a line that passes through the origin.
Let me unmute.
The constant of proportionality is the rate of change. You can find the constant of proportionality by comparing the ratios between pairs of values in the graph in the table. In the graph of proportional relationship, the y value of the 1y also tells you the constant of proportionality and the rate of change.
All right. Miss Brooklyn, do you agree with what he just said?
Yes, I agree.
All right. Cool. Look, she hit that button quick that time. Yeah. All right. Vincent just said, I'm leaving it where I can talk. He just left his on. I don't blame him. All right. So we're going to take everything that we've learned from this entire topic and we're going to summarize it, okay? So let's look at our summary. I'm going to give Miss Brooklyn another chance. Brooklyn, will you read this and then try to summarize what it's showing us, please, ma'am?
In this topic, you learn how to create an algebraic rule from data in a table or graph. In a table, the part of the process that stays the same becomes the coefficient, while the part that changes is represented by a variable.
All right, so what's happening in this table?
They are multiplying the cups of blue paint by the cups of yellow paint. No, not multiplying, but dividing the cups of yellow paint by the cups of blue paint.
There you go, girl. And every time that they do that, what are they going to get? Every time they do the yellow paint divided by the amount of blue paint?
3.
That's right. So when they get 3 every time, that's telling us that there's a constant ratio of what?
3.
Good job. That's
Three.
what I'm talking about. I didn't mean to raise my hand. I meant to clap, but it didn't work. Da-da-da. All right. So next thing I want you to notice is that right here, it's showing us that our constant is 3 because it's being multiplied by what?
1. Wait.
What letter?
X.
By x. So that means that 3 is our coefficient, okay? And that also means it's our constant of proportionality. All right, remember that coefficient just means a number multiplied by the variable. All right, number 2. All right, on number 2, let's hear from Miss Natalia. Miss Natalia, read this for us, please, ma'am. Not from us, for us.
You can determine the constant of proportionality by finding the rate of change in a graph or by figuring out how much one variable changes in the relation of the other in A scenario. The constant of proportionality is represented by the coefficient in an algebraic rule.
Good deal. All right, so looking at this in the green paint mix number 1, what do you notice, Natalia?
That is like it has an origin and it's a straight line.
All right, it does have an origin. We want to remember that it's a straight line that passes through the what?
Origin.
All right. So she's saying that she realizes that mix number 1 is what type of relationship? Proportional.
Proportional.
Okay. And so since we know it's proportional, is there any way for us to tell what the constant of proportionality is?
Yes.
How?
By looking at the algebraic rule.
Correct. And when we look at the algebraic rule, what are you looking for to tell you what the constant is?
The number.
That's right. And what is the number?
2.
It's 2. All right. And so she knows that the constant of proportionality is 2 for mix number 1. So what does the constant of proportionality for mix number 2 have to be based off of what she just said? It has to be 3. All right. There's another way we can look at this. Good. We also know on mix number 1, if we go 1 to the right, we go up 2. Every time we go 1 on the X, we go up 2 on the Y. All right. On mix number 2, every time we go 1 to the right, or we use 1 cup of blue paint, we use 3 cups of yellow. 1 cup, 3 cups. 1 cup, 3 cups. Does that make sense to everybody? Perfect. Remember, use those thumbs up tools and those thumbs down, all that stuff, so you can talk to me because you're not in class, so I can't see your face. Normally I can look at someone's face, and if they're dazed, that means they're not paying attention. If they're, got that face like this, that's a confused face. All right. If they look like this, they got it. All right. Most of y'all are like this. I don't know what that is. Tamarian, tell me.
It means we're tired. I
think. Well, I know that much. I'm trying to know where you're at, though, mathematically. All right. Number 3. Tamarian had the shades on, asleep. He just wipes slobber off his face. Golly. Golly. All right, here we go. Tamarian, read this for us, please.
You also learn how to determine whether a relationship represented by a table, graph, or algebra rule is proportional or non-proportional. In a table represents a proportional relationship. All ratios simplify to a single unit rate or a constant of proportional. In a graph,
Linear.
A linear proportional relationship cross the
Origin.
while a non-proportional relationship does not. An algebra rule represents a proportional relationship has
A coefficient.
Coefficient that represents the constant of proportionality.
Great job. All right. So, looking at this table, Angel, tell me what's happening with the pizza without delivery and tell me if there's a constant. And if there is a constant, tell us what it is.
Can I ask what you mean? Like,
Who can help her out? He's silent. All right. How do you find the constant of proportionality looking at that table, knowing that the number of pizza and knowing the amount that they cost? What would you do?
Divide.
Yeah, you would divide. What would I be dividing?
7.
Correct. By?
7 by 5.
Where's the 5?
By 1.
Yeah, the 1. 7 by 1. Because the pizza costs $7, so you divide it by 1 pizza. All right. The other
I
one.
thought it was 5 the delivery charge.
I got
so
you. That's
why
for
I
this
thought it
over
was
here,
5.
but we're not on that one yet. All right. Next one we would have to do, it says 14 divided by 2, which also equals what? 7. What's 21 divided by 3?
7.
Okay. And what is 28 divided by 4?
7.
So for all of those cases, what happens?
That's a constant of 7.
That's what I'm looking for. Great job, Kalia. All right. On the next table, what would we do to determine if there is a constant of proportionality? Madeline.
Wouldn't you do
Uh-oh, she needs some help. Help her out. Rachel, can you help her?
You would divide 12 by 1.
That's right. We would do 12 divided by 1. All right. What is 12 divided by 1?
12?
12. What's 19 divided by 2?
Wait,
No, 8.
it's not 12.
It'd be 9.5. So since it's not 12, that means that this table is not what? Proportional. Good. Now today, for your work that I need you to do today, I want you to click on My Agile Mind. All right.
Let me get on it.
All right.
I'll forget.
You're on My Agile Mind, and when you're on Agile Mind, your own Agile Mind, you're going to scroll all the way down. When you scroll all the way down, this stupid computer's messing up. You're going to screw all this stupid thing. All right. We're going to scroll all the way down, and then you're going to look for the assignment that says October 28th, 8 a.m. to October 29th. You're going to click on it. All right. When you click on this assignment, you'll notice that there are a total of 8 questions. There's 5 guided practice questions, and there are 3 more practice questions. I want you to get those done. And if you have time, you can go over your study guide tonight. Okay. We are going to try to work over some of those tomorrow, but I would really like you to be able to go through and try to do it on your own so you'll know if you did it right or wrong whenever we go over them in class, okay? All right, my boys and girls, I hope you have a fabulous day. If you're going to church, be safe tonight, and I will see y'all soon.